The existing project, the consented method, involves the segregation of sections of the canal and dewatering them and placing the dewatered sediment into trucks and transporting it to our containment sites. The new method that we're trialling eliminates all of the traffic movements. So we have, under the current consented method, around 2,000 to 3,000 heavy traffic movements. With this method, the key elements to it are a cutter suction dredge, which sucks up the sediment, transfers it through a pipeline positioned along the canal up into our containment sites, where it is then treated and dewatered in geotubes. That eliminates issues around heavy traffic, dust, potential spillage. Essentially, we've got a system with this new method that is fully contained from the canal all the way to the containment sites. There are concerned residents within the community, and we've been trying to work through that, which is one of the reasons why we've looked to introduce this method, because it does eliminate the bulk of the concerns that were raised. It also has more efficiency associated with it. Instead of having lots of trucks and excavators coming and going, this method will require really less than 10 people to operate the dredge, the water treatment elements, once the containment sites are built. Some of the issues that we have with the current method are around flood management. We have a salt marsh on the eastern end of the KopeCanal, which would require construction of a haul road adjacent to the canal in the current method. We have the dust issues, and we have heavy traffic. All of those are manageable under the current consent, and there's conditions in place for that. However, this method simply eliminates those risks from the project. The key elements to the process are a cutter suction dredge, which is essentially a suction head which removes a lot of water and the sediment at the same time. Now that sediment, if we were to try and filter it out alone, we've got fine colloidal particles in there where the contaminants are bound to. We cannot filter that without the water treatment element. The flocculants that are added to the water and the sediment and allows the fine particulate to bind together and enables us to be able to filter it out in the geotubes. Geotubes are essentially large geofabric sausages, and these fill up with the sediment and water. The water is separated out and then transferred back to the canal. Our initial bench scale trials before we set this pilot trial up were very positive and showed that we had sediment concentrations around about 1,500 picograms per gram. That's indicative of the higher range of concentrations we have in the canal. And then the filtrate, or the water that's treated and discharged, had 6 picograms per litre. Now that's already 5 times lower than the drinking water standard. So initial results that we completed led us to believe that this process was worthy of further exploration, and subsequent to that we've set up this trial. We're also gathering a huge amount of information, data from the canal during the process, so we can be informed of what potential effects we need to consider if we vary our consent application and introduce this new method. So the trial has a number of elements that are not exactly how the full-scale remediation project would go. The key differences here are the dredge head. For the purpose of the trial, we've used what's called a drag flow pump on the end of an excavator. Having any heavy machinery in close proximity to the edges of the bank is problematic in terms of bank stability. Our preference would be to use a more commonly adopted technique, which is a dredge mounted on a barge or a pontoon within the canal, and that would simply manifold into our main pipeline, which transfers the material down to the containment site. There is some very high-tech dredge heads out there now, so that are designed for the profile of the canal. For the main project, we would install a weir at either end of the canal. The current project method has a full bund, so no water, even high flow events, storm events, would be allowed to pass through the section when it's dewatered. This method is different in that a weir is set at high tide levels, and it allows water to come in just at that last bit of high tide, and it allows storm events to overtop the upstream weir. But it means that the water within the canal would be fairly static. rather than the current flow which we're experiencing. And that flow has resulted in us having a need for a silk curtain around the dredge head. That may not be necessary in the full scale. There's certainly control measures that we'd employ. The fact that we are actually wearing off either end of the canal would turn this into a static water body under normal conditions. We can mitigate against the flood risk, which means we can work right through winter with this method. All we have to do is have an alert if we have a heavy rainfall warning or an extreme event, rainfall event, and then we would shut the dredge down. It would simply stay in the canal, and then we would start up again once normal conditions stabilised. The key difference is how we get it from the canal into the containment sites. The dredge, pumping it through a pipeline, the water treatment and the geotubes would be positioned at the containment sites. This method is more commonly used by the bulk of contracting firms in the United States where they have a lot of sediment remediation. We've been putting information up on the website. We've been gathering more data. From here on in, we're actually putting all of the historical data and future data up onto the website, so spatial maps. We've got the full history up on the website now, so we've been much more open with the public about everything that we're collecting, and we're putting that up on the website, and we want that to be the central point where people can go to and they can feel like they're getting the information that they need. We've looked at this, we see it brings a hell of a lot of advantages over the current method in terms of eliminating the dust, eliminating the traffic, and eliminating potential discharges. So it actually makes my job a lot easier and makes the residents really rest a lot easier in the community, because this method actually has a lot more control over it and a lot more risk stripped out of it.